Okay guys, this is going to be part 2 of the notes that we took this past week, because if you notice, we still have reflections that we're doing. I stopped the video from this past week in the spot that I did because the last 2 types of reflection are a little bit trickier. The lines that you have to make just make it a little bit harder to count spaces to and from the points. So I wanted to give you, for these last 2 types of reflections, I wanted to give you 2 rules that you can use every time. So just a reminder, make sure you are copying down. You don't have to copy this all down again. This was what we did this past week, but make sure that anything I write in this video, copy that down on your own paper. If you need to make some more graphs, make some more graphs. But then you're going to email me a picture of your notes, or you can submit it on Google Classroom in the assignment. But then I will also, in addition to this video, I will post some pictures of homework problems. And then after you do those homework problems, you do the same thing you did with the notes. You need to email me pictures of having those completed, or turn in those pictures to Google Classroom under the assignment. So I need to see somehow that you've got the notes all done and the homework problems done, and that's how you're getting credit. So this is actually going to be the only set of notes and assignment for this upcoming week. So make sure you get those 2 things done. Okay, so I have our notes from this past week because I wanted to show you something that you should have written down then, and it's these diagonal lines, because these are going to be our last 2 types of reflections that we have to do. It's the line y equals x, which if it's positive, it's like having an invisible 1 in front of it. And then the opposite of that would be y equals negative x. Or if we're trying to find a number in front of x, we again assume that's a 1. So those are the 2 reflections we're going to do today, are these 2 right here. So I'm going to switch papers to our next note paper. And I'm going to write some things on the side here, and then I'm not going to completely fill out the graphs because I'm going to give you, like I said, 2 rules that will help you reflect over these 2 diagonal lines that you have to make. And I already had these written down, so I had to erase them. So sorry about all of the eraser marks or smudge marks that you might see, but here's our last 2 reflections. Okay, so this first one is going to be our negative slope because it says negative x, and then this one's positive. So if you think back to, I guess, 8th grade maybe, and then last year in Algebra 1, this is what your slope equation looks like. It makes a straight line on a graph, and you are given a number that's before x, and then a number at the end, which is your y-intercept. Now, if you look at these 2 equations in bold that are going to make our diagonal lines, they don't have any number after x. So the y-intercept is just going to be 0. But we don't have to write 0, but if we wrote the full slope equation, we would just have a 0 at the end. So that means we're going to start counting our spaces at 0 to make this line, because we have to have a line in order to do a reflection. So like I said on the other notes paper, our slope is like having a imaginary 1, okay, in front of that x. So your slope for this first one is a negative 1. And when we're counting spaces for slope on a graph, you need to have a rise over a run. So any number over 1 is just itself. So what we're going to do is you start counting at your y-intercept, which is 0. A negative slope means you're going to count down and then over. So we're going to count down 1, over 1, and we should make a diagonal line through 0. So here's 0, down 1, over 1, down 1, over 1, down 1, over 1. And you're basically making a point every diagonal box. Okay, so this is going to be our y equals negative x line of reflection. Okay, so if this next one is just positive, well, we're still starting at 0 because there's no y-intercept after x. So this has a slope of positive 1 over 1. Sorry if there's a glare and you can't see it, but I just wrote positive 1 over 1. Let me try and write it over here off to the side. Okay, so there's our slope. So it should just be going in the opposite direction as this one we just made. So if we're making our line, we start at 0 again. Now instead of going down 1 over 1, using our slope of positive 1, we're going to go up 1 and over 1. So every square, every diagonal point we're going to have a dot that we connect to make the line y equals positive x. Okay, so they go through 0. They're both diagonal. It's just that this one's positive, this one's negative. So since I mentioned those rules that I'm going to have you write down, there are rules if you're reflecting across either of these two lines, because what we did this past week with reflections is I had you graph these points and then I had you count spaces to whatever line you were reflecting across. But those were all vertical or horizontal. These ones are diagonal. So when you're counting spaces, it makes it a little trickier because you're counting diagonally across a graph. And some of these might be only halfway across a square. Some of these points might be 3.5 squares to the line. So it just makes it a little trickier, but I'm not saying you can't do that still. That rule or that tool that we used this past week still applies. You can still graph these points. So in this one, the points x, y, and z, you can still graph them. You can still graph square ABCD and count how far away they are from the line and count the same number on the other side. But I think these rules will just be a little bit quicker. So if you are reflecting across, I'm just going to go with our first one here. If you're reflecting across the line y equals negative x, all you do is you take your points, which are in this format every time, and you switch their spots and switch their signs. So the second number becomes the first number, and the first number becomes the second number. Now I did mention switching their signs. So you're not just switching their spots, but let's put a negative sign in front of these because you're going to switch them. Now this doesn't just mean that you make your new points negative. This means, for our rule, this means that you have to change the sign whatever it starts as. So if these points you're given are negative already, then you would change it to positive, okay? Negative would change to positive, positive would change to negative, okay? So you're switching their spots and changing their sign from either positive to negative to the opposite. Now the other reflection, the positive line, the positive diagonal line is a little bit easier, okay? All you have to do, if you're reflecting across the line y equals x, is you start with a point, and all you do is switch their spots. That's it. There's no changing of sign. You keep the sign, whatever it is. You just switch the number spots. So the first number becomes the second becomes the first. And these are going to give you your new points. So let's see what we've got with our original points, and then we're going to just write down what the new points would be. Okay? So this is an alternative to graphing your points and then trying to count to this diagonal line because it's a little bit tricky, but it is doable. Okay? So if this first one is the negative slope, okay, y equals negative x, we're going to use this rule on our original point. So if I start with A was starting as -1, +3. So if I switch their spots, the 3 is first and the 1 is second. But the other thing you have to change is the sign on both of them. So -1 is going to become +1. +3 is going to become -3. Okay, so these again, with that little prime symbol being after the letter, these are your points after you reflect across the line. It's just a shortcut. So if B was 0, 6, well, if we switch their spots, the 6 is first. Okay, 0 doesn't have a sign. It's neither negative nor positive, so it just stays 0. But since 6 was positive, I've got to change it to negative. Okay, now C, we've got 2 more points. C is 3, 5. So I'm going to change that to 5, 3, and they both were positive, which means now they both are negative. All right, and our last one is point D, which is 2, 2. Now if you switch their spots, it's still a 2 and then a 2, but they were both positive. So now they're both negative. Okay, so if you're reflecting across this negative x line, you make both changes. You switch their spots and change the sign on both. Now the positive line, it's a little bit easier because all you have to do is switch the number spots and keep them exactly how they are in terms of their sign. So if we're starting with x is -5, -2, well then after it's reflected, it would just be -2, -5. Okay, y was -3, 4. Now it's 4, -3 after it's reflected across this line right here. And the last one is z. Z was negative 1, 1 before the reflection. Now it's 1, negative 1. Okay? So I did not graph either the originals or the new points. You can certainly do that, but since we're using a shortcut here, you can just write the new points like I did and not graph them, or if you want to graph the original shape, you can also graph the new shape after it's reflected because we just came up with the new points. Okay? So use these rules on your homework if you want for when you're reflecting across these two diagonal lines. Now, the other type of question you're going to see on your homework is identifying the law of reflection. So basically, the reflection's already going to be done, and you just have to tell me where it was reflected across. What line did it flip over? Okay, and you can always tell which one's the original shape because it doesn't have any of those little apostrophes, which are your prime symbols. So I know just from looking at this first one that it started here and it flipped over to this one. This is the new shape. So to start here and end up here, it flipped this way. Okay, so it had to flip across a vertical line. Now, when you're coming up with the line of reflection yourself, you can still double check by matching up your letters and then counting the spaces, how far they are from that line that you think it was reflected across. That'll still work, or you can just eyeball it, and I can tell that this was reflected across the y-axis. Okay, now moving on to the one right next to it, right here, this is my original shape. There's no prime symbols. This one's my new shape. So it went from here over to here. So it definitely reflected across a diagonal line because if I just did a vertical reflection, it would end up here. If I did a horizontal line reflection, it would end up here. But it went from here and then up to the top right corner. So it had to be a diagonal line. And we're only going to have two options for our diagonal lines, and it's the ones that we just went over the rules for. So this is a negative line, so you know this was reflected across y equals negative x. Okay, it looks just like this one up here. All right, we've got 4 more for our notes. Now this one, these triangles here, I can tell that this was the original and this was the new. So it started here and it flipped over here. So it had to be a vertical line that it flipped over. Okay, but this is not the y-axis that's in the middle. You're always looking for the line that's in the middle of the two shapes. This is one that we talked about in our last set of notes where it's basically an equation, but you're just telling me what number this line goes through and what axis it goes through. Well, this line goes through the x-axis and it goes through it at the number -3. So our line of reflection is x equals -3. Okay, it's not the y-axis. The y-axis is right here. Our line of reflection is a little bit to the left of that. All right, now the one next to it is probably the trickiest one because it doesn't really make a normal shape. But if you follow the lines here, here's the regular T, here's U, and here's V, okay? So I guess it is a triangle, but it overlaps itself after it's reflected. So we're going from this to this, okay? So it flipped this way, okay? It had to flip over some horizontal line. And remember, if you're trying to find where that line is, we'll pick a set of points. Like if I'm looking at T and T prime, what line is right in the middle of those 2 points? That's your line of reflection. Well, T is 2 spots from the x-axis and T prime is 2 spots from the x-axis. So this was reflected across this line right here, x-axis. You can still count spaces to double check your answer. All right, now we've got 2 more. Okay, so we're starting with, in this one here, we're starting with this shape and it's flipping down here. So it definitely flipped over a horizontal line, but it didn't flip across the x-axis. We've got to find the line that's right in the middle of our sets of letters. So Z is 1, 2, 3 spots away from this line I just drew, and Z prime is 3 spots away. 1, 2, 3. So remember, just like the one above it, sometimes you have to come up with the equation if it's not one of the axes. So this goes through the y-axis, so it's going to be y equals, and then whatever number this goes through. This is the number +1, So your line is y equals 1. Okay, now the last one you could probably see in these where I had a line and then erased it. So I'll still explain what we had going on here. We started with this shape, and it was reflected up here. Okay, it started here, flipped over to the top left corner. So this was a diagonal line that it had to flip across. Okay, if it goes from bottom right corner up here to top left, it had to be a diagonal line because it couldn't just be a horizontal or vertical line. It wouldn't end up slanted like this. Okay, find the line that's in the middle of the two shapes and then give that line a name. Well, this is a positive line, so it's the line y equals x. Our two diagonal lines are either going to be this one or this one. Okay, just find the line that's in the middle that you can tell the shape flipped across. Okay, so this is all you need to have down for our notes for today. And I'm going to stop this video and then work on posting your homework questions. Okay, make sure you get these to me by the end of the week.